Alright, so hello YouTube. This is my first attempt at explaining the process of how I make vape juice. So there's a couple of important things that we need to consider here. Let's get to a little bit of math first, and then once we get the math out of the way, I'll talk about some of the instruments I use to get volumes with precision. So the juice we're going to be making today is a copy of a flavor called 7Cs. It's kind of like a fruity mixture with a hint of colada in it, a little bit of sour. It's really nice. I like it. And we're going to prepare it at 3 milligrams per milliliter of nicotine. And we're going to use a 120 milliliter bottle here. So that's give or take 4 ounces. So the formula we're going to be looking at is the concentration of the first species times the volume of the first species is equal to the concentration of the second species times the volume of the second species. So this is just like a little bit of basic algebra, and we are going to run through some calculations. I'm not going to do it for every single flavor I have here, but I'll show you how to do it for nicotine. And then I'll do it for one flavor also because the units are slightly different. So in the instance that we're trying to prepare 3 milligrams per milliliter nicotine strength of 120 milliliters, we're going to have that be on the right-hand side of our equation because typically I like to go in order. So if we have 2 here and 1 here, 2 comes after 1. So 2, I'll set that as our final concentration and volume. So we want to prepare 3 milligrams per milliliter of 120 milliliters in our total volume, right? The nicotine base that I have is 100 milligrams per milliliter, but I don't know what my volume is going to be. So before I finish writing this equation, I'm just going to do a little bit of algebra here to rearrange this. So I know that I have a C1 value. I know what that is. It's 100 milligrams per milliliter. I don't know what my V1 is yet because I don't know how much of that I need to add yet until I do the calculation to get the desired nicotine strength. I do know what my final concentration is, and I do know what my final volume is. So if you divide both sides by the initial concentration, that will isolate the initial volume variable for us to determine how much of that we need to add. So if I divide by both sides, these cancel out, and I'm left with this. Volume 1 is equal to concentration 2 times volume 2 divided by concentration 1. So we're just going to plug in numbers. I know that my concentration 2 is 3 milligrams per milliliter. My volume 2 is 120 milliliters. And I know that my concentration 1 is 100 milligrams per milliliter. So the cool thing about this is we know that volume is in units of milliliters. And we know that a concentration is equal to a mass or over a volume. So when we do our division, we're going to have some units canceling out, and we're going to end up with some units. So since we're trying to find volume, our desired unit is volume. So when we do this operation here, the milligrams per milliliter units will cancel out, and we will be left with volume. So if we do 3 times 120, that's equal to 360. And then if we divide 360 by 100, this is equal to 3.6 milliliters. And if you look here, I already circled the unit that's going to be remaining, so that's why I wrote it over here. So based off of this calculation, we now know that we need to add 3.6 milliliters of the nicotine base that is 100 milligrams per milliliter to get our desired concentration of 3 milligrams per milliliter inside of 120 milliliters. So let's do one for a flavor. So part of this recipe calls for 5% strawberry. So we need to figure out some numbers. We're going to use the same formula that we used before, but we need to figure out some numbers. So we have our final desired concentration will be 5%, which is the same thing as 5 over 100, because the percentage is a portion of 100, right? And then we also have our 120 milliliters again, because that's our final volume, right? And at this point, we are going to do a little bit of math to see how much of that we need to add. So if we do 5 times 120, 5 times 12 is 60, add a 0, 600. If you divide that by 100, that's equal to 6 milliliters. So in a 120 milliliter bottle, we need to add 6 milliliters of our strawberry flavor, which happens to be inside of this bottle here, to get the desired percentage of 5%. So that is more or less just how we do the basic math for this. Now, one important thing to consider for this is, in the example I'm using currently, I'm not factoring in the density of the solutions that we're working with because I'm making a small recipe. Now, if you make a recipe or a batch at a time that happens to exceed, let's say, 1,000 milliliters or a liter, if you're making batches that large or larger, it's important to factor in the density of the solution, because if the density is significantly larger or smaller than 1, let's say outside of 1 or 2%, then if you're making a really large batch, your calculations in this example won't correctly work. You have to factor in the density to get an accurate amount of all the ingredients you need for your solution for vaping. So now I want to talk about how I get my volumes. So I have 2 pipettes here. The one with the light blue cap here is a 1,000 microliter pipette, and it can, with precision, dispense volumes between 1,000 microliters and 100 microliters. So a microliter is a unit of volume that is a portion of a liter. So we have a liter, and then if we go 1,000 steps past a liter, I should say below a liter, that's called a milliliter, because there's 1,000 milliliters in a liter. Then if we go to a microliter is 1,000 times smaller than a milliliter. So in 1,000 microliters, that's equivalent to 1 milliliter. So the way this works is, this is a lock, so you can lock your volume. Right now it's set on 600 microliters, so that's 0.6 milliliters. But the cool thing about this is each of these little hash marks that are inside of there represent 1 microliter. So you can spin it. Right now that would be 605 microliters. And as you spin this top piece here, that's what sets the volume. So the way this thing operates is it displaces air to get your volume. So if I turn this in a clockwise motion, like this, that decreases my volume. Then if I turn it in a counterclockwise motion, that will increase the volume. As you can see, the numbers moving. So once you get your desired volume, let's go back to 600. I like to make sure that the little red arrow lines up with the hash mark, just right in the middle of it. I'll lock my volume. And this thing right now is ready to dispense 600 microliters or 0.6 milliliters at a time. So the way this works is we'll have a little plastic tip that we insert right on this little black piece. It needs to fit flushly, and you don't want any air leaking out while you're aspirating. So once we do that, we'll put the tip of the plastic that we just put on into our solution, just the tip. Then what we'll do is we will press this down. Excuse me, before we put it in, we want to press it down because we don't want to add unnecessary air bubbles to our solution. So this thing will press down. It has 2 stops on it. The first stop will give us our 600 microliters. The second stop, if we push as far as it goes, that's the second stop. And we use the second stop for clearing the contents of the plastic tip. You can also use the second stop for a technique called reverse pipetting. So in traditional pipetting, you will press to the very first stop, insert the tip into your solution that you're trying to get the volume of. You will slowly let out, with my thumb, I'll do it. I'll slowly let out the tip, the top to aspirate. I'll let the tip sit in the solution for a few seconds because I want the solution to equilibrate once it reaches the maximum draw of our set volume. Then I'll remove the tip, move over to the container that I'm going to go into. Then what I'll do is I'll press this to the first stop, wait a little bit, and then press it all the way to the second stop to try to get all the solution out of that tip. So that'll give me a very precise way to transfer small volumes. And essentially what we're going to do is we're going to end up calculating everything here. I'm not going to run through all the steps because that's just, once you see it once or twice, I think you can do the rest if you feel confident in your math. So you'll do that. And then I also have a 10,000 microliter pipette. So what this does is it's very similar in operation to the 1,000 microliter pipette, except it can accurately, I shouldn't say accurately, precisely is a better term. With precision, it can add between 1 milliliter and 10 milliliters of solution. So the way this one works essentially the same way. We have a lock for our volume. We can decrease the volume with the counterclockwise twist of this little blue piece here, increase it with a counterclockwise twist. And each of the little hash marks, it's kind of hard to see, but each of the little hash marks inside will represent a 0.1 milliliter change. So this here is 7.2 milliliters. If I go on the hash marks, 1, 2, 3, 4, 5. Okay, there's 5 hash marks, so it's a 0.02 instead of a 0.01 milliliter change. So this would be 7.1. If I go in 5 hash mark steps, that changes it by 0.1 milliliter, the volume. So this one's kind of nice for dispensing larger volumes. If you want to have a more accurate mixture, it's good to do as little pipetting as possible. So when you calculate your volumes out, you just go to your pipette and then do a little bit of division to see if you can get the fewest amount of aspirations and transfers to get the to increase the precision. Because if the more draws you do, the more transfers of volume you do, you're starting to introduce error. It's really not that critical if you're doing a small solution preparation, small batch at a time, but if you're doing a big batch, that's when it can get a little crazy. You don't want to start making mistakes. So you can get a lot of this stuff on Amazon. I usually get my flavors from the site called bullcityflavors.com. They got a pretty good price on stuff. They're not paying me or nothing. But I get a gallon of vegetable glycerin for, I don't know, it's usually between 28 and 32 bucks, give or take, on Amazon. Gallon of propylene glycol. You really don't need this much unless you are preparing like a 50-50 blend, or I don't know, a 60-40. If you have more PG than VG, propylene glycol than vegetable glycerin, you're going to want to get something like this, a big bottle. You only need, like, I would say a 250 milliliter bottle of this will last you quite a long time. And what do I use to mix with? So this is just like a little Norpro hand mixer. This thing was like not even $5 on Amazon. So it's got two little AA batteries inside of here. It's got a little button, press and holds. It rotates. I need to change the batteries. This thing's, oh, there we go. So you kind of just press and hold and it stirs and mixes just like that. So once you get everything added to your solution, that's kind of how it works. So let me make sure I have everything, and then I will prepare this juice. All right, so I did all my calculations. This column here represents the volumes of the amount I need to add of each of the ingredients. And this will be for a 120 milliliter batch. So I did all my calculations, typed everything into a little Excel spreadsheet, so I can just reference this while I'm preparing. So the first thing I'm going to do is I'm going to set my pipette here to 1 milliliter. So this is going to need to read 1,000. I know earlier I talked about pipetting as little as possible. I happen to be out of pipette tips for my 10,000 microliter pipette, so that's why I'm only using the 1,000 right now. So unfortunately, I'm going to have to do this 12 times to add 12 milliliters of the watermelon flavor. So let's go ahead and do that. So I'll set this here for a second. Pick up a tip. The tip is right here. I'm going to insert the tip right on here, nice and snugly. Not overly snug, just enough so that we don't want any air leaking out, but we also want to be able to remove it. So I'll go there. Got my tip inserted onto my pipette. I'll go to my watermelon flavor here. So I got the watermelon. Let's remove the cap. Let's remove the cap off of my bottle. And I'm going to aspirate this 12 times to get 12 milliliters. So I'll depress the plunger to the first stop, insert the tip into the solution, draw it. You can kind of see it coming up the bottle there, or the pipette tip, excuse me. Let it sit for a second, kind of wipe the edge of the tip on the corner of the bottle. Then I'm going to aspirate it right into my container, just like that. Now you see it's kind of collecting in the tip, the amount that didn't come out. So what I'll do is I will press the pipette to the next stop to try to get the rest of that out of there. So that's one. Now we got to do that 11 more times. Two. I'm probably going to speed this process up rapidly because you don't want to sit here and watch me pipette for 10 minutes, do you? Or I'll just do it for one, and then at the end, once I have everything added to the bottle, I will show the mixing, and that'll be it. So let's just do the one. So right now we have 12 milliliters of the the watermelon flavor. I'm not going to do the rest of the flavors. I decided just show you the one flavor, then we'll come back when we're ready to mix. All right, so at this point, I did the mixing off camera because the batteries in my mixer died, so I had to change them. Effectively, what you're doing is you have all of your solution, all your ingredients, and your propylene glycol, nicotine, flavors, vegetable glycerin, everything is in the bottle. Basically, what you do is you take the mixer, insert it into the top of the bottle, press and hold the button, and then move it up and down. You're going to hold it in this position while you're moving it up and down for, I usually like to go about a minute to try to evenly disperse all the ingredients throughout the bottle. This particular flavor is good to vape right now, but some flavors, when you mix them, they kind of need a little bit of time to congeal. A lot of people call it steeping, but that's basically how it's done. So I made this one for a friend. I'll be giving it to him later today. I prefer to work in like a clean laboratory environment, ideally. But it's obviously cost prohibitive to work in a lab that has all this equipment to do it the right way. But for personal use, I think this is satisfactory. It's good to wear eye protection if you can. You don't want any of this stuff to get in your eyes, especially the nicotine solution. Additionally, that solution, the nicotine solution, is permeable to your skin. So what that means is if you get a drop of it on your skin, it'll leach through your skin into your circulatory system, through your blood vessels. It's not the end of the world if you get a drop on your hand. Just go rinse it off. But you don't want to have prolonged exposure to a large quantity of this on your skin. You could get sick from it. So it's definitely advisable to wear gloves. Try to wear shoes if you can that are closed-toed, long pants, eye protection, long sleeves. But other than that, that's pretty much the process. Thanks for watching.